Hello Lana, how do you do? Welcome to Manifested Online Classes. My name is James Kenyani. We are going to continue with our lesson on similarity and enlargement, and today we are all together going to look at something new, and that is enlargement in the Cartesian plane. That will be our lesson today. So the lesson will be enlargement in the Cartesian plane. One asks, what is the objective of all that? What is the objective of all this? The objective is to enable the learner perform transformations under enlargement in the Cartesian plane. So I'll go through the objective. It is to enable the learner to perform transformations in the Cartesian plane involving enlargement and center of enlargement, the origin. So learner, somebody is asking me, what is the origin? This is the Cartesian plane. It is not the first time we meet that. That is the y-axis. This is the x-axis. This is the origin. For those who don't know the origin, it is that point 0, 0. So to commence the lesson, to understand this in an example, so learner, that is the first example we have. Consider a point A, 1, 1, transform it under enlargement scale factor 3, and the center of enlargement, the origin. This is the center of enlargement. So straight to our Cartesian plane, we know what we've been doing: image distance and object distance. The image distance is equal to the object distance multiplied by the scale factor. So step number one, we identify A. That is A. That is point A. So under enlargement, we've been drawing a line from the center of enlargement through the object as we look for the image. That is exactly what we are going to do, learner. We'll draw a line from this is the center of enlargement, 0, 0. That is the point 0, 0. It is the center of enlargement. We'll draw a line, just prolong. So the point we had earlier should not go. So we learned that image distance is equal to what, learner? Image distance we learned earlier is equals to object distance times scale factor of enlargement times scale factor of enlargement times scale factor of enlargement. So I'll go straight to my Cartesian plane, learner. I'll move to my Cartesian plane. So So I'll get that distance. Know it's how much. Then I'll double it from there, triple it, because the center, the scale factor is that. So if I look well, that is 1, 2, 2.7. 2.7. So here, if it is 2.7, 2.7 times 3 will get 8.1. 2, 4, 6, 8.1. That is 8.1. That is A prime. Look at A prime very carefully. There is something happening there. What are the coordinates of A prime? So A prime, look at it well. A prime, you'll find A prime will be what? 3, 3. So in the enlargement, you will discover from what you've used, image distance multiplied by object distance. So you realize image of A is A prime, which is 3, 3. What has happened, learner? Look at 1 and 3. Look at 3 and 3. There is something that has happened in the coordinates. 1 and 3. What is the relationship? 3 times 1. 1 times 3, you get 3. 1 times 1, you get 3. So we realize if we have a point, very exemplary there. If you have any point on the Cartesian plane xy under enlargement scale factor k, the image will be that enlargement scale factor k multiplied by the coordinate of x. Take also the scale factor, if it is given as 10 or 8, but I've used a, multiplied by y. This will always happen on the Cartesian plane. It will always happen. So if I had 2, 2, under that scale factor of enlargement, it would become 6, 6. I'll multiply 2 by 3 and the other 2 by 3. That makes us move to another example. Makes us move to another example. I can create space here. Let me create space here, for example. A square A11, B21, C22, and D12 is enlarged with linear scale factor 1. The scale factor is 2, and 2, the scale factor is -1, with the center of enlargement as the origin. Find the images of A under the first enlargement where we have 2, and the second enlargement 2 where we have -1. So this is what we are proving there. So in 1, A prime will be what? You'll just take the scale factor. It is 2. It will be 2 times 1. You'll get 2. You'll also come, so you'll say it will be 2 times 2, you get 2. Also take 2 times that one for y, you get 2. You come to B, learner. You take the scale factor, 2 times 2, you get 4 learner. You'll also take 2 times 1, you get 2. You'll come to C. 2 times 2, you'll get 4. And 2 times 2 again, you'll get 4. You'll come to D. 2 times 1, you'll get 2. 2 times 2, you'll get 4. So you can call this A prime, B prime, C prime, D prime. You come to the second one, where the linear scale factor is -1. You simply take the scale factor, multiply by the coordinate. -1 times -1 times 1, -1. -1 times 1, -1. You come to B, double prime. -1 times 2, -2. -1 times 1, -1. You come to C, double prime. -1 times 2, -2 learner. -1 times 2, -2. And D, -1 times 1, -1. And lastly, -1 times 2, -2. So where was the emphasis? You take the scale factor given, multiply by the coordinates, each of the coordinates of the object, you'll get the object of the image. That is, if the center of enlargement is the origin. So as we note, those are the images under those enlargements. Note what has happened. This is very important. This is very important. We are going to look at another example, example 3. So there goes a very good example for us. Enlarge a triangle A, 2 and B, 4 and C, 3, 4 with linear scale factor 2 and enlargement center being the origin. What do you notice about the areas of the two triangles? So straight to the Cartesian plane. So since we had used that for demonstration, let's look where A is 2, 1, 2, 1, 2, 1. So you can clear that so that it's not congested. We start plotting the points. The first one is 2, 1, 2, 1. That is A. 2, 1. Move to B, 4, 1. B. And C is what? 3, 4. 3, 4. 3, 4 is somewhere here. 3, 4 is here. Somewhere there. So you draw your triangle. That is C. Those are the coordinates of A, B, and C in that example. So you join the vertices. So that is my triangle learner, where A is, you had it as 2, 1. My B is 4, 1 learner. My B is 4, 1 learner, and my C is 3, 4. Straight to our enlargement. The guiding factor is still there. Image distance is equals to object distance times scale factor of enlargement. So number 1, join from the center. Join each vertex to the center of enlargement, which happens to be the origin. Learner, join that clearly. Join to the center. Sorry, that's not the center. The center is the origin. It is here. So I'll still join C to that. Look at what is happening, learner. I first of all join or the center of enlargement to each of the vertices. Then I join to C to B also. So I said from that, image distance is equals to object distance times scale factor of enlargement. In this question, the scale factor of enlargement is 2. So you look at what will happen. Look at what will happen because of that can measure from this point. That is 10.2. 10.2, the distance there. So for the image, it will be, from here I'll measure 20.4. It's here. It's here. That is C prime. Let me just first of all get the points, then we shall move to the coordinates. I'll come to A. That is 4.1. Double that, it will be 4.1, 8.2. Comes here. That is A prime. A prime. I'll move to B. B, that is 8, so this will be 16. Correct. That is 8. So this will be 16. That is B prime. Note how we've got that. We've doubled, I've measured this distance to that, and then I've doubled it. I've been doubling it. So I'll join the vertices. Join the vertices, learner. So a learner who was attentive with what we did in the first case, you'll obviously know the coordinates of this, because we said we multiplied by the scale factor, but we've done it because they say seeing is believing. Seeing is believing. So that is the vertex there. Join to get my image. I've got my image, learner. Got my beautiful image there. A prime, B prime, C prime. If you look well, what are the coordinates of these? Look that. Look, learner, well. That is 8. And you drop down 6, 8. In fact, it is 6, 8. What has happened from what we learned? You take the scale factor and multiply by the coordinates, like it was 2. 2 times 3, 6. 2 times 4, 8. What about this one? This one is 8, 2. Does it prove what we are trying to prove there? Yes. 2 times 4, 8. 2 times 2, 2. We come to A. This is 4, 4, 2. Does it work out with what we proved there? Yes. 2 times 2, 4. 2 times 1, 2. We now come to the relationship of the area. I can call this area 1, area 2. Let's calculate area 1 because they want the relationship of the areas. Relationship of the areas. Let's go to area 1. Area 1 is a half times base times height. So I'll move, the base has 2 units, 1 and 2. So it's a half times 2. Learner, the height will count 1, 2, 3. 1, 2, 3 times 3. That is 1, 1. That is 3. If we are using centimeters, it would be 3 centimeters squared. I come to A2. It's a half, the base, the height. So it's a half times, the base is, we are moving from 4 to 8. We are exactly moving from 4 to 8. So those are 4. And the height, you are moving from 2 to 8. So that difference is 6 times 6. 2, 1, 2, 2. So you get 12 centimeters squared. You discover A2 is 4 times. A2 is equal to 4 times A1. A1. The area of the image is 4 times the area of the object. And looking well, our linear scale factor, which is K, was given us 2. You'll discover later that the area scale factor is equal to K squared, which will be 2 squared. It is 4. We've actually proved there. The area scale factor will be the linear scale factor squared. So the linear scale factor was 2. So our relationship there is area 1 is 4 times area A. In any enlargement, if you are given scale factor like 8 for linear, the area scale factor will be 8 squared, and so on and so forth. Given 7, it will be 7 squared. So for that you'll get a good assignment to so that's the assignment for the learners who do not know Mathematics for Kenya Schools by Patel. It is here. So in the book it is on page 94. You'll work out number 2, number 3, number 4, number 5, and number 6. You'll get a good experience of enlargement in the Cartesian plane with the center as the origin. Thank you very much for the audience. Enjoy the assignment. Let's meet in the next lesson. Bye.